Lesson 29. Benign Metabolites.
Alright, let's talk about benign metabolites. And to do so, allow me to back up first and talk briefly about biodegradation. Now, you know, biodegradation is one of the key components of green chemistry, and in fact, there's a whole principle devoted to the question of biodegradability of compounds. The reason for that is that many of the molecules that we use currently are made to be very stable. That makes a lot of sense in products where they're used, but then when they enter the environment, their stability can be a liability because they may reach levels that are harmful to health, environment, and natural resources if they stick around in the environment. So one of the goals of green chemistry is to make sure that molecules are biodegradable and don't stick around in the environment for too long. A great example, of course, is what you've certainly seen recently in the news, the question of plastic pollution in the oceans, where plastic is really made to last, and we're seeing the consequences of that. So if we want to design materials, molecules, that are biodegradable after their use phase, we also need to make sure that we think about the metabolites that they produce as they are broken down. So even a benign compound that may enter the environment may produce a metabolite that could be problematic. Awareness of these processes is important, as sustainable design must anticipate product breakdown and not just the product itself in order to minimize harm to humans and the environment. This is especially relevant to biologically active chemicals, such as pharmaceuticals, herbicides, or pesticides, where small changes to chemical structure during physiological processes could lead to unintended effects.